In this video, we'll talk about the cross-entropy loss. And this will be our total loss or cost function for logistic regression, and we'll also apply it to other models for classification. So first we'll talk about maximum likelihood estimation, and then we'll see how to go from maximum likelihood estimation to cross-entropy loss. And we'll just do it for logistic regression, but the same methodology applies to all the models that involve classification. So we have a classification data set, and we're all going to look at the bias parameter. We have the samples for y equals 0 in red and y equals 1 for blue. So it turns out we can calculate a likelihood of observing the following sequence. And if you recall, the logistic function gives us the probability that y equals 0 or y equals 1 accordingly, and we can calculate the likelihood. Now this example, the line seems to be better at fitting the data, and we can calculate the likelihood accordingly. We get 0.46. And for the final line, which seems to do the best, we can also calculate the likelihood. Our goal is to obtain the parameters that maximize this likelihood function. So just like flipping a coin, we can come up with an expression for the likelihood. And here's an idealized plot of just one parameter. We want to find the maximum point. So it turns out we can take the log, and as you can see, it didn't affect the position of the maximum, just the shape of the function. And because we want to minimize something, we simply multiply it by a negative number. Now, as you recall, the location of the minimum is in the same place as the position of the maximum. And we simply average it out. And it turns out the minimum of this function corresponds to the maximum of the likelihood. So here's the actual expression, and we can implement it in PyTorch as follows. And it looks something like this. And there's contours all over the plot surface. And that's it.